Hello everyone, welcome to my channel. So in these videos, we will continue to talk about the topics in probability. So in this video, I want to talk about the probability distributions and the probability mass functions. So mass function is a way to describe the probability distributions when the sample space is discrete. So first, let me talk about what's the definition of a probability distribution. So a probability distribution is a way to describe the probabilities associated with a random variable for all the possible values of this random variable. So for example here, if we denote the random variable as capital X, then we can write down this probability distribution by a probability mass function. So then let me write down what's the definition for a probability mass function. So probability mass function is only defined for a discrete sample space, and we know the random variable on a discrete random sample space is a discrete random variable. So for a discrete random variable, we can assume the possible value of this random variable denoted by the small letter. So here we denote this by x sub 1, x sub 2 until x sub n. So it's a finite number. And then we can define the probability mass function as a function satisfies three requirements. So the first one is the value of this function at any point should become a non-negative number. So this is actually the reason we have this requirement, because the probability of is always a non-negative number. And the second is for the sum of this function at all of the points should equal 1. So this one is because we know in the probability we have the sum of the all weight discrete sample space should become equal 1. So this is the second requirement for our axiom of probability. So if you forgot this, you can look at my videos about probability and axiom of probability. And the last one of this requirement is actually the definition of our mass function. So the value of this function at each x point is equal to the probability of our random variable x at each point. So this actually is a true definition of our meaning for the probability mass function. Okay, so the first two requirement is by the axiom of probabilities, and the last one is by the meaning of our definition of a probability mass function. So now let me give you an example of this, and let's use this example to explain how to compute the probability mass function when we given an experiment and a random variable. So let's look at this example. So assume we want to play a coin game with 5 coins. So we will flip them, and for each of the coin we will have two possible results, a head or a tail. But then in this game, what we will do is we will stop immediately after we get a head, or we already finished the flip of all these 5 coins. Then let x be the number of tail we get. So here, this x is not how many coins we will flip, or any other thing like about head. This x is be the number of tail we will get. And the question is ask us what is the probability mass function of x. Okay, so by this one, the first thing is let us look at what is a possible value of our random variable. So here our random variable is x, and assume like if we flip one coin and then just this first cone, we already get a head. So what this means? This means we will need to stop immediately. And in other words, because for flip one cone and get one head, it means there is no tail, or in other words, there is a zero tail in this situation. Okay, so this zero tail is one possible value of our random variable. However, if we flip two cones, and what we have is we will get a first cone with a tail. So because now we get a tail, so that means we can continue our flip. So that means we will continue to flip the second cone, and if the second cone we get a head, then that means now we will stop. Okay, and in this situation, what this means? This means we will get one tail, one head. And because our random variable x, we only care about the number of tail we will have. So in this situation, the value of our x should become 1. And then what we can do, we can continue to think about what will happen. So it's like if we flip the first cone, we get a tail, then we can flip the second cone, and then we will get a tail again. So now we can continue to flip the third cone. And if the third cone we get a head, so that means we will have two tails. So this situation, it means actually in this question we can continue. We will have like two tail, so that means two tail from the first two cone, and then a third cone get a head. And then we can also have the case like we will get three tails. So that means we flip in total 4 cones. We get tail, 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 and a head. And also we can have 4 tails. So that means we flip all of the 5 cones, but we get head as the last one. And also we can have the other case is 5 tails. So for 5 tails, it means we flip all of the cones, and for all of these cones, we all get tail. Okay, so this means what the value, possible value of our x. So for our x, we can have a range, or in other words, the possible value as 0, 1, 2, 3, 4, and 5. So this is a possible value for our random variable. And now in this situation, what we will have is question asks us what is the probability mass function. So probability mass function is the probability of x random variable equal all of the possible values. So we need to compute probability of x equals 0, probability x equal 1, probability x equal 2, and x equal 3, x equal 4, and x equal 5. This is what we need to do to get the probability mass function. Okay, so for the first, what this means? This means we flip one cone, we get a tail. So because here for all of the cone, they didn't say the cone is fair or unfair. So that means generally this is common sense. We think if they're in the question they didn't specific this cone is fair or unfair, it means the cone is fair. So that means if we flip one cone, the probability we will get head or tail is equally likely event. So that means here in this situation, the value for this is 1/2. And then for the situation of we get x equal 1, so that means we flip 2 cones. The first one is a tail, so that means 1/2. And the second step is we flip the second cone and we get a head. So that means here this is a 2-step probability. So that means for this 2-step situation, we will have 1/2 times 1/2. So the answer of this is 1/2 square, and you can compute, use a calculator. So here I just keep this. And then for the third situation, x equal 2, now what we have? We have the first one equal, first flip, we get a tail, second we get a tail, and last we get a head. So that means we will have a 3-step probability, and we need to get the product of them. Okay, and similar situation for all of the following one. So for all of the following one, we will all have a several step experiment, and we will compute all of them. Okay, so here just the most important thing is for the last two. So the last two is we get 4 tail or 5 tail. So for the 4 tail, it means we actually flip all of the coins. We get 4 tail on the first 4 flip and get a head on the last one. So that means it's 1/2 to 5 power. And then for the x equal 5, actually the situation is similar. We get 5 tail for each of the steps. So it's still equal 1/2 to power 5, because for the cone it's a 5 cone, so the probability we get a head or tail are all 1/2. So that's why we have this answer. Okay, so then this actually is already the answer for this question, but we need to, if this is in your exam or in your major, what we should do is we should check is our probability mass function is correct or not. So how to check this? We need to check the 3 requirements of our definition for a probability mass function. So the first, second, and third. The third one actually is more straightforward, because this is how we can compute our result. So the only thing we need to check is the first and second one. So by our computing here, it's upwards, we can get the value of each of this probability actually is a non-negative number, right? So this is really trivial here. So the second one about the sum of them is equal 1. So we will need a calculator to compute them. So actually, if you compute the answer here of this probability here, you will find 1/2 plus 1/2 square until plus 1/2 to 5. You will get this answer, and this answer is equal 1. So this is, you can use calculator to check this, and this is what you should do when you do maybe project of probability, or is this what you should do in your exam or assignment. Okay, this is my explanation of probability mass functions, and I hope you like these examples. And in next lecture, I will talk about what is a cumulative distribution function. So we generally call this as a CDF. So yeah, so hopefully I will see you in my next video, and please subscribe this channel.